Welcome to lecture series on database management system. In today's lecture series, we are going to see about transaction and concurrency control topic. So before going into the topic, let us see what a transaction is about. So what is the general meaning of transaction? Any operation that is happening between a client and a server is called as transaction. So sending any operation, be it any kind of operation that is happening between the client and server is called as the transaction. So let us take banking transaction as an example. Now, person A wants to transfer 100 rupees from his saving account to his checking account. And similarly, he transfers rupees 200 from his money market to checking account. And at last, he withdraws 400 rupees from his checking account. So here totally 3 steps are mentioned. So in first step, he is transferring 100. In second step, he is transferring 200 rupees. And in third step, he is withdrawing 400 rupees. So these 3 steps are happening between the client and the server machine. So this is an example for transaction. So here we have given an example transaction which is done by the client. So in the initial step, he is withdrawing 100 rupees. Then he is reading the deposit. Again, he is withdrawing 200. Then he is reading the deposit. Then he is withdrawing 400 rupees. And he is commit marks the end of the transaction. So he is committing the transaction. So this is example for transaction. Let us see what happens in the server side. So in the server side, initially, when the client initiates the transaction, open transaction function marks the beginning of the new transaction. So once open transaction function is invoked, a transaction identifier will be issued. So this transaction identifier is unique for all the transaction. So this will remain as long as the transaction is in progress. Once the transaction is completed, to end the transaction, close transaction function is called along with the transaction ID, which is issued earlier. Commit marks the successful completion of the transaction, whereas abort marks unsuccessful completion and returns the index where the transaction is aborted. So this is an example for the transaction we have seen earlier. And account, here the operation that happens in the account interface as well as at the branch interface is mentioned. And here comes the definition of transaction. So a transaction, it can be defined as consecutive sequence of steps or consecutive sequence of operations. So these operations are mentioned in the form of steps, which happens from between the server data as well as the client. So here it is something that is transferred from the server data to client machine or from the client machine to the server data. So as any transaction is happening, it has to abide by 4 rules, or it has to abide by ACID properties. We call it as ACID properties. A stands for atomicity, C stands for consistency, I for isolation, and D for durability, which we will see in the later part of this presentation. Mainly, it has to satisfy a rule called as all or nothing principle. Either the transaction has to happen in a whole, as a whole. That is, the transaction has to be completed successfully, or it should not take place. There should not be anything like a partial completion of the transaction. So this is all or nothing principle. And it is not only one transaction can happen at a time. Multiple transactions can happen at the same time, and transactions can run concurrently with multiple clients, as well as the transaction can be distributed across various multiple servers. These are various properties of transaction. So here are various stages where transaction can fail. So here, initially, the client, say for example, the customer A has detected 100 rupees, has debited 100 rupees from her savings account, and he has added 100 rupees to his taking account. If failure happens at this time, it will not cause the loss of money, but it it says all steps cannot be repeated. So similarly, after see the last step, it is commit transaction. So this marks the end of the transaction. This is a point where there is no return for the transaction. So failure at this particular point needs some corrective action. So failure happens in the sense, for example, we have entered the amount in the ATM machine, and when the withdrawing is in process, before we receive the cash, if the ATM crashes, this is a failure. So here we cannot undo the changes because already the system has started processing the withdrawal process, and it is due to the ATM crash that we couldn't receive the amount. So this kind of failures needs corrective action. So this is the asset property that we have been discussing before. In traditional databases, the transaction that is happening has to satisfy the asset property. So atomicity means all or nothing principle that we have discussed earlier. Consistency in the sense if more than one transaction is happening concurrently, uh, it has has to be ensured that the transaction is in consistent state. The transaction should let the server in consistent state. That is what consistency is about. Any updates that is being made to the transaction has to be updated properly. Third one is isolation. So, though more than one transaction is happening concurrently, each transaction should not interfere with any other. That is what isolation is all about. And durability, uh, despite the hardware failures or despite the software crashes, the system has to stay up to date. The system has to be updated completely. So that is what durability is all about. So these are various properties of transaction in traditional database. So far we have seen what is transaction and what are asset properties. We have explained transaction with the help of an example. Hope you understood. So in the next lecture video, we will discuss about concurrency control and various concurrency control problems in transaction. Keep watching. Thank you.